This is 6.5a of algebra. So we've talked about inequalities before, something like x is greater than 3. And we make our number line, we stick 3 in the middle, we'll stick 4 and 2 next to it. This tells us that it's an open circle. So an open circle at 3 and it would go to the right. And that would be our equation, right? Well, now we're going to look at linear inequalities. Something like this, where there's an x and a y in the equation. So if you think about, we've worked with linear equations, right? Something like y equals 2x minus 3, right? And let's say we plug in 2. 2 times 2 minus 3, that's 4 minus 3, so y equals 1. So this is the point 2, 1 is on that line, right? That 2, 1 is a solution. If we look at that same inequality, but we change it so that we have the greater than symbol. Now if I plug in 2 for x, y is greater than or equal to 2 times 2 minus 3, which is 4 minus 3, which turns into 1. Now the point 2, 1 is a solution. Or sorry, not 2, 1. Yeah, 2, 1 is a solution. Right? We plugged in 2 for our x, we got out 1. But also 2, 2 is a solution, right? Because 2 is bigger than 1, right? If we plug in 2 for y. 2, 3 is also a solution, right? We can plug in 3 for y. 3 is bigger than 1. 2, 4, right? And I could keep going and keep going and keep going. Just for x equals 2, there's infinitely many points that are going to be true, that are going to be a solution. Whereas when we were just working with a linear equation, there was only that one point there. So our graphs are going to look a little different because we have more options than just the ones that are along the line, right? When we're graphing a linear equation, it's just a line, and any point that's on the line, that's a solution. But when we're looking at linear inequalities, like this one, we're going to have a lot more solutions than just the one that's on the line. Okay, so we are given the equation y is less than or equal to 2/3 x plus 4. And they want to know, is 3/6 a solution? So we're going to plug it in. I'm going to plug in 6 for y. And I'm going to plug in 3 for x. 6 is less than or equal to, you can change this so that the 3 is a fraction, right? And 2 times 3 is 6, and 3 times 1 is 3. So 6 divided by 3, which is just, right, 6 divided by 3, which is just 2, plus 4. And we get that 6 is less than or equal to 6. And that is true, right? 6 is less than or equal to 6 because 6 is equal to 6. So this is true. So this is, in fact, a solution. If, however, it had been 6 is less than 6, that wouldn't be a solution, right? Because 6 is not smaller than 6. So if it comes out true, it's a solution. If it comes out false, it's not a solution. Okay, so when we are graphing, remember when we were graphing inequalities like the x is greater than 3 kind of thing? Our inequality symbol tells us whether it's an open circle or a closed circle. Now our inequality symbols are going to tell us if it's a dashed line or a dotted line, whatever you want to call it there, or if it's a solid line. So if it's a dashed or dotted line, that's less than or greater than, and our solid line is for less than or equal to or greater than or equal to. So let's try graphing. We've got this equation here, y is less than or equal to 1/2 x plus 1. So I'm going to draw in my axes, and I'm going to start graphing this. I'm going to graph this just as if it had an equal sign. So I'm going to put a dot at 1 on my y-axis. I'm going to go up 1 to the right 2, up 1 to the right 2. I'm also going to go the other direction, so I'm going to start here again. Go down 1 to the left 2, down 1 to the left 2. And I'm going to connect it with a solid line. Because this symbol right here is less than or equal to, so it's a solid line. If it was just less than, it would be a dotted line. Okay, once I drew in my line, I'm not done. I need to still shade one of the sides. So you need to plug in a point to your inequality. I suggest plugging in the point 0, 0. Okay? As long as your line doesn't go through 0, 0, right? If our line went through 0, 0, don't use it. But it doesn't go through it, so I'm going to use the point 0, 0. So 0 is less than or equal to 1/2 times 0 plus 1. 0 is less than or equal to 0 plus 1. So 0 is less than or equal to 1. And that is true, right? 0 is smaller than 1. Since it is true, I go to the side that has 0, 0, and I'm going to color it in. I'm going to shade it in. Anything in this area is a solution, okay? Since we have a solid line, anything along the line is a solution. You could pick that point, this point right there, and that's a solution, right, on that line. You could pick any point inside here, and that's a solution. If you choose a point out here that is not a solution, it's not going to work. If you're not sure if you didn't shade, if you're not sure that you shaded it right, you may pick any point in here. Perhaps you pick 1, -2. You can plug it in and it'll come out true. If it didn't come out true, you shaded the wrong side. Okay, let's try one more. Let's try y is less than 2x minus 2. Okay, so I'm going to draw my graph back in. Okay, so I need to put a point at -2. And I need to move with my slope. I'm going to go, remember this is 2 over 1, so I'm going to go up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. And I can also go backwards if I want, so down 2 and to the left 1. And looking at my symbol, I need to make this a dotted line. A dashed line. So, there's my line. Now I need to figure out how to shade it. So I'm going to plug in my point. So I'm going to plug in 0 for y. It's less than 2 times 0 minus 2. So that's 0 is less than 0 minus 2. So 0 is less than -2. 0 is smaller than -2. That's not true. So I do not shade this side. Okay, this is the side that has the point 0, 0. I'm not going to shade that side because it came out false. I'm going to shade the other side. And again, if you're not sure if you got it right, choose a point in your shaded area and plug it in. Check it out. And there's your homework.